I'm George Self. This video is one in a series designed to help with the R labs for BASV316 Introductory Methods of Analysis. This is Lab 4, Visualizing Descriptives. Descriptives are things like the mean and the median. We talked about those in an earlier lab. In this lab, we're going to visualize those, and we'll be using what's called box plots. This is the first lab that we're doing where we have some sort of visual representation of data. Box plots are some of the simplest visuals. They're very effective and very useful, and they're very commonly used in research reports. I start out here with something about visualizations. I point out that a vector can have just a whole bunch of numbers, and a scientist can look at those numbers and maybe get something out of it. But if you can do something with those numbers to put them in a visualization like this, all of a sudden relationships begin to become apparent. Now that visualization is what's called a box plot. And here's a box plot from the MT Cars data frame. This is the Motor Trend Cars, some basic information about cars. And this is information now, a box plot about the horsepower for cars. I want to show you, using this summary data, which we saw in an earlier lab, the minimum horsepower for all of the cars in this data frame was 52, and that's where this lower whisker is found. The first quartile is 96.5, and 96.5 is here at the lower edge of the box. The median is 123, and the median is this heavy line in the middle of the box. The mean is not represented in a box plot. The third quartile is 180. That would be the top of the box. And finally, the maximum value, 335. One car has a lot of horsepower, and it's represented by this little circle at the top. Now, the reason it's separated out like that is because this is what's known as an outlier. This one value, this 335, was much, much larger than most other cars. This must have been some kind of a high-powered sports car, and it had a lot more horsepower than most cars in this entire data frame. So it's represented by a small circle as an outlier. Now the next thing, I show you how these whiskers, that's what these things are called at the top and the bottom, how these whiskers are calculated. To be honest, you really don't need to spend much time trying to figure this out, because we'll let R do that for us automatically. So here's our demonstration. Now this demonstration actually contains 4 different examples of a box plot, and you'll see how how the R interface handles those 4. Let me click this and run it. And we see the 4 box plots. Now I will mention, and it's here in this yellow box, that R creates these box plots in a graphic area so that they're really squished down. You'll notice the box plot you see here, it doesn't look like the one that I showed you earlier that was all spread out. However, to get a spread out version, you can click this double-headed arrow, and it will pop that out of, let me make this a little bit smaller so you can see it on the screen here. That will pop the box plot out. So now you can copy and paste this into your deliverable for this lab. If your box plot does not pop out like that, there's a good chance that your browser is set up to not allow pop-outs. If that's true, you'll need to try to figure out how to permit pop-outs on your browser. If you have trouble with that, you can check with some of the tutors. They should be able to help with that question, or you can contact me and I'll be glad to help you. Now this was the fourth box plot. Let me go back to our script. We did create 4 of them. The third box plot was the shape. So if I go back to plots, I can back up one, and here's the rock shape. Again, I can pop it out if I want to. And there's that rock shape box plot. Let me close that. I can go to the second box plot. This is the perimeter, or the first box plot, the area. And all of these are now available in R. I'm going back to the script because box plot is this command. Now I will point out I've also printed the summary. The summary is not necessary. I only did that so you could see the various values and compare them to the box plot to see how the box plot is generated. As our guided practice, I'm going to paste that box plot command in. I want to create a box plot for sepal.lengths. And these are capital letters. And there is no main, and it's the iris data frame. There we go. And run this. Oops, I had a typo. I have IRI instead of iris. So let me go back here and do that. And now run that. And there it is. There's our box plot for the iris data frame, sepal length. And you can see it there. So if I go back to the script, I'm going to copy this out. And the activity, I will paste that in. I need to generate a box plot in the cafe data frame for age. Run that. And there's that box plot. To submit that for grade, I would go ahead and copy and paste this larger version into my Word document. Next, outliers. I've already described what an outlier is. It's a value that's especially large or small. You can see in this particular box plot for rock shape, there are 3 outliers. In order to calculate outliers and find them, we're going to use this command boxplot.stats. And let me run this. You get a lot of stats. Now these are the values that R uses to generate a box plot. So these are the values that are behind the box plot. What we're interested in is this very last value, the $out. These are the outliers. And you can see there are 3 outliers for this particular data frame. For the guided practice, so I'd better come back up here and copy this one. Box plot stats, and I will copy this. Come back down here and paste this in. And I need the iris data frame. And I want the stats for sepal.width. And run that. And the outliers here, there are several of them. There's 4.4, 4.1, 4.2, and 2.0. So there's actually 3 high outliers and 1 low outlier. Our activity for outliers, I'm going to copy this again. Copy and paste it in here. Find the outliers for miles in the cafe data frame. Cafe and miles. And run that. And the outliers there are 292 and 209. Grouped box plots are very useful. That's where we have more than one variable plotted on the single plot. You can see here we've got from the MT cars data frame, the number of cylinders and the weight of the cars by the number of cylinders. Not surprisingly, 8-cylinder cars are heavier than 4-cylinder cars. The demonstration, and I will point out that we're now going to add color to these box plots. I have here some information on what each of these lines do. And I see 3 different examples of generating grouped box plots with color. So let's just run this and see what we end up with. And I'm going to pop out this third one. Oh, you know what? Let me go back up to the second one because there's only 3 in here. It's maybe a little simpler to see in this video. So here we have brakes by tension. This is a warp, a weaving data frame. You can read about it in our appendix. You can see that for low tension, we have this many brakes. For medium tension, we have this many brakes, and for high tension, we have this many brakes. And there's one outlier here. What may be important is to notice also the colors. Now, in the appendix for this lab manual, I have a lot of information about color and how you can add color to the data. You'll notice here that I'm using color is rainbow, or color is heat, or color is topo. And again, in the appendix, I show examples of all those colors so you can figure out what they are. So, for our guided practice, well, I'm going to go ahead and just let me copy this one because it's a little bit simpler and I think it's enough. And I will paste it in here. I want a box plot of the Morley data. So the data here is going to be Morley, where speed is grouped by EXPT, that's experiment. The Morley data was measuring the speed of light. So we have the speed is grouped by experiment, EXPT. 5 colors from the terrain color fountain, terrain color palette. Colors, and I need 5 of them, I said. It does not require a main. Now, main puts a title on the top of the thing, so I'm going to get rid of that. And let me run this. Speed not found. Well, I must have a typo here. Speed has a capital letter. That's why I had a problem with it. So let me do that and run. There we go. I'll pop this out so we can take a look at it. And there's the Morley data, speed by experiment. So experiment 3, the speeds were fairly well grouped, except there were some outliers. Experiment 1, the speeds were more scattered out with one really low outlier. And notice there are the colors. Now the activity, I'd better come over here and copy all of this. I will paste this in using the cafe data frame. A box plot of length when grouped by meal. Length grouped by meal. Using 4 colors from the topo color palette. And I need 4 colors there. And run. And there we go. So breakfast had this length of meal. Notice breakfast is a fairly short meal, but this would be like someone coming in just for pie in the evening. A really short meal. The longest meal here is dinner, with one outlier. Someone had a really quick dinner there, I guess. That's about it for this lab. Good luck with it. As in all of the labs, please do not get too frustrated. If you run into a roadblock and don't know how to proceed, please contact me and I'll be glad to help. I'll be seeing you online.